Question 11. The diagram shows a semicircle with center O. So the center of the semicircle is there. Two of the angles are given. We've got the 67 here and we've got the 32 there. What is the value of x, this angle shown here? So, as is the case with any circle theorems question, every single angle that I'm drawing here is possible or related or relevant or, could be something that we figure out. Like every single one of those angles that I've shown there may or may not be used in the process of answering this question. There is more than one way of doing it. I actually think there's more than two ways of doing it. I'm going to show one way and then I'll leave you to see if you get the same answer based on whatever method you've chosen. So from our diagram here, just identifying some of the circle theorems that are relevant before I go through the motions in finding, actually doing the calculations. This center here, any of your circle theorems involving centers, we have, of course, an angle in a semicircle. So any lines connecting to here and here, which we have if I follow this and this, that will give us a very messy looking right angle there, straight off the bat. We also have our center giving us two isosceles, actually three isosceles triangles. So we have the blue one there, making these two the same. We have the red one, which I'm going to overlap here. That red one will give these two angles as being the same. And we also have this pink one giving these two angles as being the same. Technically, there is also angle at center is twice angle at circumference. Quite a subtle one to spot, but it is there. This being the angle at the center. So if I use these 2 points as our chord, so the angle at the center here is equal to twice the angle at the circumference there. So whatever this is going to be half of that. That's another circle theorem that could get used in this. So as I look at it, the most obvious one is the isosceles triangle. So these two being the same gives us that as a 67 straight away. The next one that I see is the angle at the angle in a semicircle is a right angled. So from those two lines there, we have a right angle here. Being very careful not to join it up there. So it's from this line and that line. That's where a right angle exists. I can then figure out the size of this angle here. Like I said at the start, just start finding any and every angle that you possibly can, and you will pick up marks. I do 90 minus 67 for that one, which is going to give me 23 degrees. So I can put 23 degrees here. I don't need it for what I'm about to do, but I'm just going to find it because of the fact that it's part of it. 67, 67 added together, and then take it away from 180. Will give us the size of the angle I'm about to show in pink. So that there is 46. There's two ways of getting this angle that I'm about to draw in red here, because either angle at circumference is half angle at center, will give us 23, or if I look at this isosceles triangle here, I also get 23. So really I should put that in green, because the size of this angle here is 23. I didn't actually need that, but anyway, I've got 23, so I could have gone and figured out the pink one, then the green one to get this green one, or I could figure out the 67, use the right angle to get that 23 there. After you've got that 23, we have this isosceles triangle here, giving us 32 and 32. So just highlighting the fact that this, all of this is 32, and therefore our x is going to be that 32, subtract, what color will I use? Gray. Our x is going to be that 32, subtract 23, which will give us 9 degrees. Done.